feedback whether my screen is visible or not, or am I audible or not. So you may confirm in between. So is my screen visible to you?
Yes, sir.
Yes.
Yes, sir.
So myself, Avnish Tripathi, I will be the instructor of this class, and with help of other faculty members, I would be taking this course. I mean, in terms of the lab experiments and the tutorial, all these things. So, but largely, by and large, I am the instructor and I'll be taking all the components by and large. So, what we are going to have in this course, as I told, that we need to have some prerequisites, like we must have gone through these courses or at least have some understanding about these courses. So I hope that you have completed analog electronics EN 106. Is that all right?
Yes, sir.
Yes, sir.
Okay, so where you must have learned about diode, BJT, FET, op amps, oscillator, voltage regulators. So am I correct?
Yes, sir.
Good. And the second course, which is optional if you have taken good, otherwise any of these courses would work. So network theory also, I think you have completed in your first year.
Yes.
Right? So all these things, network theorems, transient analysis, two-port network, network synthesis, all these things you must have gone through. Although I know that your semester just ended few days back, and again you have started with the new semester. So many of the things would be very fresh in your mind, but still, if you are missing few points, you may go back and look at those contents again, and that would help in this course as well. And some understanding I expect from you about the programming language C, C++. So we will not be dealing directly with C or C++, but we would be dealing something like hardware description language HDL, which is very similar to what you must have seen in C or C++, whatever language you must have read on your own or in the class as part of curriculum. So that would help. If you have not done, still you have some confusion or something, you may refresh those things. So these are the prerequisites you should have. So definitely go through those things. Now, what we are going to have in this course is, maybe initially I will have some basic introduction about why we should have digital electronics. What is the need of that? Of course, we have already learned about analog electronics. Why do we need digital electronics? And if at all we need, can we completely replace analog electronics with digital electronics? Or is it the scenario that both of these are supporting each other in the practical scenario? So these questions we will be figuring out what we should have. Then, of course, when we are dealing with digital electronics, there are few basic things we need to understand about this. For example, different number systems. So we are very much familiar about the number system with base 10. So that is in our day-to-day routine we use. Then there are some more number systems which are not at this base. They have different base, let's say 2 or 8 or 16. Why these are necessary, why these are required, and what we do in this. So these kind of basic understanding we will try to have. Sometimes I think in maybe CBSE or some other board, they also take these things in the class 12th curriculum. So some of you must have gone through. That is also all right. Then we have Boolean algebra. So when we are having these kind of different number systems and different states, which we call as logic states, we definitely have some algebra associated with that. So when we are doing 1 plus 1, we know that from our arithmetic it is 2, but it may not be true for all the number systems. So which is what we will be understanding from this Boolean algebra. Then there are some digital integrated circuits. So this basically indicates that how are we realizing these circuits or these conditions or these logic states? How are we realizing practically? Or do we have something ready-made available in nature which we can use directly for our application of digital electronics? If not, then what to use, what to do? So after all this, we will go little bit further into the Boolean functions, which means little bit bigger equations and these kind of things, where we will be realizing some circuits. So these circuits can be divided in two parts, whether it could be combinational circuit or it could be sequential logic circuit. Combinational logic circuit mostly or always depends on what is given as input, and the output is completely dependent on that. There is no other thing which can change the output. Whereas in the sequential logic, you will see that the output not only depends on the input, but also depends on the previous state of the output. What was the previous output, and then what input you are giving, that will decide or dictate the next output. So that is something called as sequential logic. So in our day-to-day routine, we encounter both these things equally. We do have some systems which mostly operate on what input is given and what output comes out. And we also have systems which depend on the previous state. The best example is your clock. If your minute is rotating by 60 cycles or 60 minutes, if the minute needle is going, then your hour value depends on what was the previous hour value. If it was 1 a.m., next is going to be 2 a.m. If it was 3 p.m., next is going to be 4 p.m. It cannot be random. But however, if the second needle is there, always it rotates once, the minute is going to be increased by 1. Of course, from 1 to 60 again, it could be sequential. But if we see the increment, yes, always one increment. So both the things are there. Then on the same lines, we have counters. Counters means we are incrementing something or decreasing something in a sequential or non-sequential manner. So these are all part of what we are going to study in our course. And then there would be the combination of what we have seen earlier, the combination of digital electronics and analog electronics, which is where we convert one signal to another signal. So whenever we have analog, we convert it to digital, and whenever we have digital, we convert it to analog. So this must be giving you some hint that yes, in real world scenario, when we are dealing with our practical systems, we do need both the systems like digital electronics as well as analog electronics. Some things are very well defined and very easy to do in terms of analog systems, and some things are very easy and very convenient to do in terms of digital. So when we are doing it in some real world application, we definitely need both. And finally, what I was telling as the hardware description language, so this is where I need some understanding from your side about the C or C++ language. So this will help you in understanding the hardware description language. So whenever these circuits, what we are understanding throughout the course, when the quantity goes beyond, let's say you are synthesizing thousands of circuits together, it is not possible to do it manually. You have to have some mechanism to do it in an automated manner. And this is where we actually look for some language which is called as hardware description language. We put a for loop or if else loop or some other and this logic over there, and then we code it what output or what circuit we want. So this is where we will be dealing with hardware description language, and this is where you will be introduced to embedded systems, which is a very strong important component for the today's industry. Okay, so moving towards some of the suggested books, I think already you have the list, so you may refer any of these 6 books or all the 6 books. So you are free to choose, and one thing I would suggest that you definitely focus on your class notes and the lectures. Okay, another caution for all of you when you are attending the class. I have two monitors basically. So one monitor is shared as the whiteboard which you are seeing, which is shared with all of you. The second monitor is basically kept for seeing all of you, which is where I am taking your video feedback. So I can see only Rajendra there, no one else. So this is just a caution for you. Don't take this for granted that if I am sharing some screen, I am not looking at you. If you are nodding, I am seeing that, yes, you are responding to that. So keep your videos on in between, do not turn off and do not leave the lecture also. Again, attendance is not mandatory, but definitely it will affect your performance. Okay, so these are the suggested books and some credit distribution, what we are going to have during the course. Of course, we are all doing the course for getting some marks, getting some grades, apart from gaining the knowledge. So the contact hours are distributed like this for the week. There would be 3 lectures. So it is on Tuesday, then Thursday and Friday, and 10 to 11 is the timing for all the 3 days, 10 to 11 a.m. There is one tutorial, 1 hour for all the batches. So this is planned on Thursday between 2 to 6 p.m. and you already have the schedule which batch will attend when. Then we have 2 hours for the practical. So we have some practicals to do, but of course we cannot do it on hardware as long as you are there at home and we have restrictions due to COVID. So we will try to do some experiments through the, should not call it experiment, but we will try to do those practicals on a simulation platform. For example, MATLAB could be one option or some other suitable option I would try to figure out. So this one thing I would expect that you all should have MATLAB on your system. So I hope that everybody is having this thing. Is that correct?
No, sir.
No,
Okay.
sir. No, sir.
And why is it so?
We don't use that.
No, it's not clear. Can you say again?
सर अभी तक MATLAB का यूज नहीं आया था सर.
Okay. So now what you can do, you can go to Institute Computer Center website, ICC IITR. There you will find link to install MATLAB. You can create your login. You will be given some official license, and from there you can install MATLAB. So that is very, very easy to do. Once you have the institute login, you have the license to install it on your system and you can use it. So also you should have some good configuration on your system if you are trying to run some simulations. So at least 4 to 8 GB of RAM you should have, and some memory, at least 500 GB or 250 GB hard disk you should have. So this is what is recommended typically for, because nowadays MATLAB is a little bit heavier, so that's why they recommend these configurations. So I hope that by whenever this next week we are starting the lab, so before that you all are ready with your MATLAB installation.
Yes.
Fine. Yeah, any response?
Okay, sir.
Good. Now, for the marks distribution, these are the weightages given for your total grades what you get in this course. So classwork, basically whatever you do in your assignment, that will have some weightage of 20 marks. This is your practical, which will contain another 20 marks weightage. Then midterm examination will again contain 20 marks weightage, and end-term examination would contain 40 marks weightage. So this is very, very evenly distributed, which means that even if you underperform in any of the examinations, still you may have some reasonable grade. You will not be losing lot of marks over there. So that is why it is distributed in this manner. So try to do well at least in these two components, because this is something which you are doing without any pressure, without any tension. So compared to MT and ET where you have examination environment, so chances of doing better in CWS and PRS is better. But again, I am warning all of you against cheating or copying. If I find any two or more answers same or similar, or having the same steps or having the same mistakes, which is also very common when you are copying from each other, then all those answer sheets, all those people would get 0 marks straight away. And I tell you, in any number system, 0 has the same value, whether you take any base, whether 2 or 1 or 10, anything. So 0 has the same value. So no need to worry that which number system I am following. Okay. Now, regarding the assignments, typically we will have 10 assignments throughout the semester. But this number actually depends on your performance. If you perform well, which includes without going by these unfair means, if you perform well, then this number may reduce. But if you are not performing well, then I will have to increase this number so that I can have some justified grades over here. So again, it's your performance which is going to decide that how many assignments you are going to have in the semester. But typically the number is 10. It may increase or reduce. Next thing is the simulation. So here we have 6 simulations as of now, which were being taken in the course throughout the semester. And here actually some of the experiments are very, very trivial. Some could be good. We may try to modify some of these experiments according to the present industry need or what is more relevant to present scenario. We can modify these according to our need and our requisites, whatever we have. So be prepared for that. So if you are understanding the concepts well, you will be able to do the simulations or the practicals very easily. But if you try to just focus on grades and marks, you might lose both the things, the knowledge as well as the grades. So my way of teaching is always have focus on knowledge, gaining the skills and gaining the knowledge. If you get these two things, rest assured this will follow. But if you focus on this, even this may go away. So this is very, very clear instruction for my class, and I hope that you all understand it very, very well. So I have a couple of questions again from the CR. So typically there are like 173 students in the class, right? If I'm correct.
Yes, sir. 177.
Okay, so far I see around 150 students only in the group. So I don't know why this deficit is there. So please ask those who have not joined to join it as soon as possible, and definitely before the next class, which would be on Thursday. And also the distribution, how it is there from P1 to P8, I would like to have that. Second thing is anyone, let us say, is having any difficulty, they are not able to get the video, or they are not able to share their doubts or something else. So you may directly contact me on their behalf. So this is for the CRs to do the job. Fine?
Yes, sir. Yes, sir.
Okay. So one more thing I wanted to share, I'm just missing that. Let me go back and see what is there. Okay, so this is covered. Fine. So I have already instructed you to install MATLAB. That is also fine. Again, there also, if you have some difficulty, do share with me as soon as possible. Which means take this week's time to solve that issue. Now, yes, in the class also, when we are attending the lectures, of course, it is getting recorded. But what I expect you that you be there in the class, you attend it live as well. Recording would be there for the complete semester, for the complete entire course, but I would recommend that being there in the class live, you may ask questions which are doubts which you are not able to understand straight away in the class. So if let us say you come back to me after 10 classes that I did not understand something in that, something which happened 10 classes back, so then I will not be able to help much, because we must have gone way ahead than where you are and know where you are struggling. So this is then your responsibility. That's why I would recommend everyone to attend the class live, and as much as possible keep your camera on, so that it gives me the feedback that how you are responding to that, how you are taking that, whether you are able to understand the concept clearly or not. So sometimes if you are not understanding, I change my teaching style as well. So which is why I need feedback. Fine. Okay.
Sure.
So this was the introduction regarding the class and the structure. So now I would stop the class over here with a question for you. Which I have asked in the beginning also, that if anyway we have analog circuits existing in the industry and all the other places in this world, why do we need digital circuits? Or I can go one step ahead. Once upon a time we had analog computers. Now all are totally replaced by digital computers. The question is why? What is so special about the digital circuits or digital computers or digital computations? What is so special that it has completely replaced what was once the charm of for this world? What has completely revolutionized the information technology and everything? So why is it so? What is so special about digital circuits or digital electronics? So this is one question for you. So in next class, I would start the lecture from here, and I would definitely expect some response from you. So there are, apart from me, there are 140 people listening to this lecture as of now, and I expect at least 20–30% of them to respond. And if let us say that number is not as per the expected guidelines or as per the expected things, then I may call names and start asking. So be prepared for that. Okay, so we can stop the class over here for today, and we will meet again on Thursday at the same time. So thank you everyone, and good, thanks for starting the recording. So yes, someone can take the responsibility if I forget. Definitely start the recording at the beginning of this class. Thank you.